All right, as for today though, we are continuing through graphing, so everything graphing related that we had been doing, we are continuing with that material in through chapter 4, right, and chapter 5. Basically, that's what we're covering in the next several weeks, leading up to the midterm. Now, good news, we should recognize a lot of this is continuing on what we saw in chapter 3 stuff. Graphing a system of equations, but now we're going to look at some terminology that goes with that and some other techniques. But let's start with the one we're familiar with, the intersection method. This is exactly what we just did on the quiz. Draw your coordinates, and I saw some people not doing this. I was like, it is very helpful. Then I graph the point. This is slope intercept form, y equals mx plus b. What is the y-intercept here?
7.
What is it? 0, 7, 0, 7. And then what is the slope here? -1/1. Well said as well, right? We like to say that as a fraction. Lots of points to make sure our graph is nice and complete. All right, for the other one, what is our y-intercept? 0, -1. And what is our slope here?
3/1.
3/1. Now, just visually, I can identify what is the intersection here.
It's 3, 6.
No,
2, 5.
I think it's 2. And is it 5 or 6? 5.
Oh, it is.
This is also important. I was like, I saw some miscounting for partially because I saw people not writing their axes, right? If you write your axes, it should be double check the count, all right? And you can identify that. Now, be aware, we can also do this with algebra. And you should do it. Most people that I saw make the mistake only did it visually and miscounted. Set y equal to y. We set our two equations equal, and then we have a pretty easy algebraic problem to solve. Get the numbers to one side and the x's to the other. X equals 2, so that coordinate looks correct. Then plug that. And you can plug it into both of them. Plugging that value 2, all right, into both equations, and oh look, okay, so -2 plus 7, that's 5. 3 times 2 is 6 minus 1, oh look, that's 5. So we have the 0.2, x equals 2, y equals 5, all right? Both graphs line up, so that confirms both what I see visually and algebraically. Again, there's two ways to do it, so you should never be incorrect, right? The whole point is checking ourselves. I was like, if we don't have the solution, that's how you make sure you don't make a mistake. All right, so some terminology. Consistent and inconsistent. So gonna be 4 verbs here, all right, that we want to make sure we understand. Consistent is when a graph has at least one solution. Inconsistent is when the graph has no solutions. So I have two equations here. Y equals 3x plus 4. And that's 0, 4 is the y-intercept and a slope of 3/1. And then y equals 3x minus 4. And by visual inspection, what do you see about these two lines? They're parallel. How do we know that algebraically?
It's the same.
They have the same slope. They have the same slope of 3/1. Again, always good to be specific, All right, and so that means where do they cross? There is no intersection. These lines are then referred to as inconsistent. There is no solution between these two equations. No intersection, we can also say no solution. So, all right, inconsistent, all right, and consistent. Up here, do these lines cross?
Yeah.
So is this consistent or inconsistent? Consistent. All right, the other two definitions, dependent and independent. Independent means you have two separate and distinct lines. All right, they're basically independent, they're individual lines. All right, dependent means that one line is a multiple of another line, and essentially they are the same line. Let's grab the first one. And then in order to graph the second one, all right, my red line, what do I have to do? I need to solve this for y equals mx plus b.
You have 3x plus 2 plus 2. So they're the same.
My goodness, they are the same. One is just a multiple of the other line. All right, these are the same lines. And these are what we call dependent lines. Now, as a note, all pairs of lines meet two definitions. All right, so the solution of these two lines, since they're the same lines, this is what we refer to as an infinite number of solutions. All right, the other way is you can say X is in all the reals, however you want to say it. Because it's all the possible values they overlap, every single value of X. Since they have an infinite number of solutions, all right, are these lines consistent or inconsistent?
Inconsistent.
Inconsistent means there are no solutions.
This is all the solutions, so.
This is all the solutions, and this is important in the definition. Consistent means at least one solution. Is there at least one solution here?
Yes.
Yeah, there's a lot more. Once again, this is our wording of at least one, right? At most, at least, all right? So at least one, there's way more than one. There's an infinite number. So these lines are consistent and dependent. All right, so tracing back. We had inconsistent lines. Are these lines independent or dependent?
Independent.
Those are the two options. Independent because they are two separate lines. They are two distinct lines. They never cross, but they are independent. So these, all right, instead of parallel lines, are independent and inconsistent. And all the way back, are these the same line or two different lines? Two different. So are they independent or dependent?
Dependent. Independent.
Independent. So notice every set of lines we have meet two definitions. This is the most common case. We have two separate lines that cross somewhere, right? Most lines are consistent and independent. These two cases are actually the special cases. Parallel are inconsistent and independent. And the same line, multiples of the same line, are consistent and dependent. So that is some verbiage. Now, I typically don't care about verbiage here and there, all right? But these four definitions are important because when we identify various types of lines and how they relate to each other. So intersection is by far our most common way of solving equations. All right, we graph them, we set the y's equal, then we find the x and then solve for the y. There are two other methods, substitution and elimination. Substitution is the one that most people like the most because you take one set of lines and plug it into the other. Elimination, you multiply in order to see if you can cancel a term. I never specify use this type or that type. It's all just what you prefer. But substitution tends to be one of the easiest methods. And when you have equations that start in a particular way, it really lends themselves. This method with this solving this set of equations, I really want to do substitution because this one that I've underlined in black already is set up as x equals, and I can plug that in for x into my other equation. We did a little bit of this back in chapter 2 as well. Once you have that, I've turned something that had two variables into a single equation with just one variable. All right. So what do I need to do here? Rainbow. Saw some mistakes with the rainbow on the quiz. All right. Rainbow is so crucial. And then what do we do in between every rainbow or algebra step?
Combined terms.
Simplify, yes. Combined terms is the fancy way of saying simplify. So yes, simplify whenever possible. And then we have a very easy equation to solve.
Wait, yeah.
Want to bring it the other way.
Yeah. Like,
Once I have one solved for a value, then I can take that number and plug it into the other equation. And this is why substitution is nice, because on the other end, it already says x equals. Now, be aware, you can leave this as x equals -1, y equals 1, or you can write these as point pair form, right? Remember, when we write point pair, it's always x comma y. Okay, so always make sure that you're ordering those correctly, even though we found the y first, then the x. But make sure when you write, if you write this as point pair form, x comma y.
Question though, wouldn't you flip your negative y though?
Wouldn't I flip my -y?
Don't you want a positive?
Yes, that's why I divided by
okay.
-1 here.
Okay.
You're absolutely correct.
Okay.
Yes, I need that to say y equals, not -y equals. That's why the very last step to divide both sides by -1. And that's what -1 divided by -1 make +1.
Okay, yeah.
The other method, elimination, and it really, like, whether you use intersection substitution or elimination, again, it's whatever the problem lends itself to. Some people are like, I'm always gonna do substitution, that's fine. But certain cases, elimination lines itself up really nice. And particularly, that's when you can set your terms underneath each other. And I can just add the two equations straight away. Sometimes you might need to multiply by a number first. But this one, I can literally see that I have +2y, -2y. I can sum this just down, and one of the variables will go away. So I have 3x plus x, that makes 4x. And here's the big part, +2y plus -2y makes 0. It goes away. So that's when elimination really has a strength. By definition, it is called elimination because you are eliminating a variable, right? The method substitution is called substitution because you're subbing in one of the variables. And then 4 plus 6 makes 10.
And divide by 4.
And divide by 4.
Well, x is 10 fourths.
Same thing, your last step, regardless of whether you use intersection elimination or substitution, it's always plug back in to find the missing variable. And then always good to refresh 6 minus 5 halves. What do I do?
-1.
-1?
How many halves did you say?
6 minus 5 halves.
Multiply by -2/5.
No.
No, just put it over, put 6 over 1, and then. You'll find the common denominator.
Common denominator, thank you. Always common denominator. That's 6 over 1 multiplied by 2 over 2. That's 12 halves minus 5 halves. Now what do we end up with?
6. Wait, no, hang on. Can't math.
7 halves. So I was like, the common denominator, it's never going away. Now, admittingly, that's one that I can do in the calculator, but when I'm dealing with something like 16/7 or whatever, like, you want to be able to deal in fractions, Larissa.
Put 7 fourths, not 7 halves.
Oh, because I was already dividing by 2. I was like, I'm working too hard. So the whole thing is always, all right, common denominators are not going away. Divide by -2, which is -2 over 1.
This is where I.
Okay, so let's do this slower then.
That's how I divide fractions.
Fraction divided by a fraction, what do we do?
Common denominator.
Nope, no
No.
common denominator.
Oh, this is when you flip it.
Leave it, change it, flip it. Leave the top, change division to multiplication, and multiplying by the reciprocal. Leave it, change it, flip it. Again, this is arithmetic, right? This isn't even algebra. And then flip the bottom. Notice what happened. I left 7/2, change division to multiplication, leave it, change it, flip. Fraction divided by a fraction, and initially that was just a number. Whenever you have a number, but you're dealing with fractions, that always goes over 1. That's the other big part. So then this becomes -7/4.
Why does it become -7? Cause you still
Is it
have
'cause
the.
they're-
Because when you multiply fractions, you multiply straight across. 7 times 1 is 7, 2 times 2 is 4, and the negative, positive times the negative is negative.
Okay, I was just curious, is it because there's a negative in there?
Oh, yes. Yeah, this is positive, this one's negative. Remember that the signs, it can go in the, this negative can be in the numerator or it can be out front. Right? The negative can go wherever you want, right? This is why in the slope, where do we always put the negative? In the top. All right, I just left it in the bottom because that's where that 2 negative, it was a
Isn't
negative
it the
2
number
initially.
of negatives that matters, not where it's at?
The number of negatives, you're absolutely correct. Yeah, not where it's at. Okay, that is absolutely correct. All right, so dealing with fractions. Fractions are never going away. Yes, can we convert to decimals? Is halves and quarters pretty easy decimals?
Yeah.
Definitely, okay? But you want to be able to deal with them, especially at this. I mean, this isn't even tough ones, right? It's not even like the ones we started with. All right, then the best part, the part that we all love. Word problems, application, all right, interpretation, communication. That's what actually makes it good, which is why I was emphasizing this stuff so much. This is so important, right? The units and or more, less than, all right? That phrasing, okay, is what signifies the context that you're dealing with, all right? The number is only half the answer, okay? So every time with a word problem, take a breath, don't panic, one piece at a time. A student's average after 4 tests is 78.5. What score is needed on the 5th test in order to raise the average to 80? All right, we do a lot of averages because averages are everywhere, right? It's also a big concept in statistics. So with an average, how does averages work again?
Add them all together and divide by how many there are.
Okay, so if I have 4, if I have 4 tests average to 78.5, help me out, how do I set this up?
It would be x plus x plus x plus x. divided
All
by-
X's?
Well, x, A, B, C, D.
All right, yes, definitely can't call it all X's because that just becomes 4X.
Yeah.
All right, so yes. And since X is already way at the end of the alphabet, let's start at the beginning. A plus C plus D, all right, all divided by 4 makes 78.5. All right, what score is needed on the 5th test to raise the average to 80? So now what do we have?
A plus B plus C plus D plus E divided by 5 equals 80.
Very well done. Setting up the problem, that's the hardest part from here on out, is just details. That is a good question. How do we solve this? Always remember, what do we hate?
Fractions.
Fractions. So what should we do first?
Multiply by 5.
Multiply, specifically, let's multiply the right one by 5 and the left one by 4.
Oh,
Oh, I was like, what?
I'm gonna get, I was like, these are two equations, right?
I thought we were just updating. Yeah, my bad.
We're just doing both, right? So this becomes 400.
4 is 40.
But 78.5, I definitely need help on. And so now I have two equations. What can I do with them?
Seven equal.
Can't be set equal.
Solve for E.
Yeah, we need to solve for E. And that's important too. Remember what we're looking for. We're actually looking for E.
Just do divided by 1, 2, 3, 4, divided by 4.
Too many people are talking. Brittany,
Divided by 4.
that just gets us right back to the top.
Okay.
Maddie, what did you say?
Just minus 314 from 400.
Specifically, okay, yes, you are logically jumping ahead. Technically, what we are doing is A plus B plus C plus D equals 314, which means it just substitutes in right there. Which means 314 plus E equals 400. And yes, exactly as you said, Maddie, then it's simply just minus 314 from both sides. E equals 86. And it actually doesn't, that's not a, there are no units here. That's not a percentage. That's not a, so you don't want to say 86% there. Be aware that's a mistake, because what if that test is out of 500? Okay, what if that test is out of 172, right?
Test score of 86.
Yes, like, I mean, at best, that point, this is one where I'm okay with 86. I was like, there's no real like units or context there. The score is 86. What?
You say points on it, I don't count.
Points on it?
Yeah. So, no.
It doesn't say points. It doesn't say, like, it's score, an 86 score. I mean, at best, you can say an 86 score of 86, yeah. But it's definitely not percent or anything like that.
Not an at least a score.
It is not an at least. You are absolutely correct there, right? Okay. Main score needed fifth test to raise average 2. That is actually exact. These are equalities, not inequalities. That is a good observation as well.
So a score, but I'm just kidding. 86, right, got it.
Okay, the perimeter of the state of Wyoming is 1,280 miles. That is a truth fact. The width is 90 miles less than the length. All right, find the width and the length. This also comes back to one of our big ones, right? We don't have to know a lot of formulas, but everyone should know the equation for perimeter of a rectangle.
It's 2W plus 2L.
Yeah, perimeter is 2 L's plus 2 W's. We are then told that 2L plus 2W equals 1280. And then, all right, for other equation, the width is 90 miles less than the length. Remember, one sentence at a time, or even one few words at a time when you're reading the equation out. What's the other equation here?
W equals 90 or L minus 90.
Oh, very good observation as well. This is the difference between, this is not a straight mathematical equivalency. 90 miles less than the length. So actually it's not 90 minus L, all right? Make sure that you have L minus 90. That's, English doesn't translate perfectly, so we have to read that out. Once you have two equations, and the big thing is what we've been doing here without saying it, in order to solve for two unknowns, you need two equations. Now notice, up here, I had at some point, I had 5 unknowns. I can't solve for what's the score of test A, B, C, or D. I don't know what that is, and I never will. I know the average of them is 78.5, but we're only trying to find, right, the 5th test. If I want to solve for both L and W, I need 2 equations, right, to solve for 2 unknowns, 3 equations for 3 unknowns, 4 equations, 4 unknowns, etc. So with this, all right, this is one that lends itself to substitution again. Let's take the W and plug it in. get multiple variables down to one variable. And then what wonderful thing do we get to do? And then simplify. And pretty basic solve. $13.60. $14.60. Once I have L, then I can plug that back in to find W. Is that good?
No,
No, why not?
30 miles.
Units. All right, context. Setting up the equations, all right, is the big part. The rest is little details, and then units, right? Context at the end, that's the other big part. The beginning and the end, right? The middle is just details with practice. Basically, you can do on repeat, all right? But the setup, right, and the context at the end. Patrick's age is 20% of his mother's age. 20 years from now, Patrick's age will be 52% of his mother's age. How old are Patrick and his mother now? So big thing here. Percentages. When we write equations, what do we need to make sure we do with those?
Put them in the
Usually not fractions.
decimal.
Decimals, right? Make sure we move them and turn them into decimals. So let's read this out, all right? Patrick's age, let's call it P, is, what is it is? Equals 20%, 0.2 of multiply his mother's age. M. Now, here's the tricky one. 20 years from now, Patrick's age will be 52% of his mother's age. So that starts pretty close, 20 years from now. So how do I involve that?
P plus 20.
P plus 20. All right, will be, that is the future tense of is. So 0.52. And then, is that it?
Yes.
That's it, right?
Wait, how old are Patrick and his mother now?
So here's the big part, all right? 20 years from now, okay? Patrick, I have plus 20 on him. Does his mother not age?
Plus
Oh.
20.
And here's the big part. Actually,
Plus.
it has to be M plus 20 and in parentheses because, all right, Patrick is 20 years into the future, right? His mother is 20 years into the future. That's one of the trickier types of setups, all right? Because it's basically the same equation we had above, but you have to make sure you add 20 to both people's ages. Once you have that, again, the solving should be relatively simple. Let's simplify this down one more step. Once I have that, all right, so now that I have that equation solved down, I actually have P equals 0.2 M and P equals this. So this one I can actually use the intersection method and just set P equal to P. Once I get the mother's age, then I can plug that back in. So currently Patrick is 6 years old and his mother is 30 years old.
Please go, just a second. Okay, that's right.
Yes.
How did you get 30 for him?
So dividing negative 9.6 divided by negative 0.32.
Oh,
So I was just slowly solving this down, right? I brought the negatives. I set the two P's equal, my two equations here. Right? I brought the 0.52 over, 0.2 M minus 0.52 M makes negative 0.32 M equals negative 9.6, which I brought down from this equation. And then just divide, right? Because I'm solving for M. This is dealing with all decimals. Like I said, I was like, we have to be able to deal with decimals, all right? Because it definitely doesn't make sense to have this as fractions, all right? So, but need to still be able to deal with decimals. Decimals are just numbers, just like fractions, all right? Not everything is integers, all right? Decimals, fractions, integers, want to be able to seamlessly transition between all of them. Now, be aware, this also reminds me on the quiz, I saw some people doing guess and check. I can guess and check this. Guess and check takes a lot longer. And if the answers are decimals, it takes forever. If their ages was actually, let's say 6.3 and whatever the equivalent 20% of that would be, all right? Guess and check, you will spend forever trying to guess and check even a single decimal, let alone 2 or 3 decimals out. All right, so we want to figure out the algebraic approach to solve these always. And it always starts right here. The initial equations. This is what you need to practice the most. The rest of this will come. All right, the more problems you do, the more solves you do, you will eventually get good at just solving. But setting up, reading through the problem and actually breaking it down, making sure it logically all makes sense, that's what takes the most skill. All right, one more here. Sky Meadow Gardening Inc. carries 2 brands of fertilizer containing nitrogen and water. Gently Green is 5% nitrogen and Sunsaver is 15% nitrogen. Sky Meadow Gardening needs to combine these 2 types of solutions in order to make 92 liters of a solution that is 12% nitrogen. How much of each brand should be used?
Just like the garden on fire.
So notice when I usually create my variables, I pick ones that make sense. P and M. I was like L and W. I was like, because I don't like to initially define my terms. However, the other approach is you can initially identify your variables. X equals amount of gently green. Y equals amount of sun saver. Now, this case, I'm defining my variables mostly because, well, gently green, I would use G. Sun saver, I would use S. Why is that problematic? Why is S as a variable problematic?
It's a 5.
It often looks like a 5. You want to, if ever possible, avoid OTS. All right, way too often I see people use those variables and their T's become their pluses and their S's become their 5s. And so I was like, now, if you want to be, as long as you are conscientious of that, you can use those variables. But I see more mistakes than non-mistakes when try and get fancy. So the other thing, all right, amount, what are we using as our units of volume here?
92 liters.
Liters, yes. So, all right, never hurts to just identify, all right, if you are going to do this method, and this is a good method. Like I said, I tend to skip this because I will worry about my context at the end, all right? But I was like, sometimes it's good for people to initially set up, okay, I'm dealing with liters, X is gonna be this variable, Y is gonna be this variable, right? Whatever is most helpful to you. Also, I just like, we use X and Y way too much, so I just get tired of using them. Okay, so our equations, this is a mixture problem and it's very, very common. Combining two of anything, right, always has basically the same setup. First, create an amount equation. That is the amount of gently green plus the amount, all right, of sun saver will create a total amount. So some amount of gently green plus some amount of sun saver creates a total amount, and we actually have a number for that.
92.
So that's our easy one. The other one is it's either the price, right? Or the percentage. Basically, it is the breakdown of whatever you're dealing with equation. So gently green, which we have called X, all right, is 5% nitrogen. 5%, make sure we write that properly. How do I write that?
0.05.
0.05 X plus 15% sun saver is nitrogen. And I am creating a 12% solution.
That's 0.12.
Total solution. So notice I have, and this is where I need to pay attention. Percent of nitrogen times the amount. Percent of nitrogen times the amount. Percent of nitrogen.
And the amount.
And what goes right here?
The amount?
What amount?
92.
92. So this one is super important to like pay attention to your units, because that's percent of nitrogen times liters. Percent of nitrogen times liters, percent of nitrogen, I need a liters. All right, so pay attention to your units as you set this up. If I don't have that 92 there, because a lot of people basically get it without that 92, but if your initial equations are wrong, it's all a mess from there, okay? Once I have that, again, we're ready to solve, that's it. I was like, this is what I want everyone to focus on, because this is the thought part. Translating that math into the equation, and from here, it's just details. So let's simplify this down one step. Once I have that, let's take the other one, and substitution seems to make the most sense here. And it doesn't really matter, so let's do y equals 92 minus x. I'm gonna plug that in. and simplify away. And this one, actually, this emphasizes the point I was just making on the last problem. $27.6. Trying to do this with guess and check will take you forever. All right? Again, 27.6 and 64.4. Those aren't even bad decimals. But the problem becomes trying to guess and check and trying to like make those values up. You will just spend forever trying to find that in between decimal. Set up the equations and then algebraically solve them.
Going on down.
Go back up real quick.
What's the matter?
The very last one you got going. The y equals 92 minus x.
The very last line?
Oh, you have. Okay, I'm sorry.
Go ahead.
I messed it all the way up.
Oh, one little mistake at the top. Oh, were you solving it? And you like
Yeah, and
made a rainbow error or something?
Yeah. So.
Okay, so, all right, last part, important part. Okay, X was gently graded. So 27.6 liters of Gently Green and 64.4 liters of Sun Saver will create 92 liters of 12% nitrogen solution. The more the more problems we do, the more make sure that guess and check is a failed option. I even think I wrote it on a few of your tests about it's a bad approach, okay? Algebra works every time. Guess and check only works if the numbers are nice. And it's super inefficient, all right? The worse the numbers get, right? And worse as in decimals and weird fractions, all right? The worst guess and check is going to be on you, all right? Adapt to algebra. There's a reason, all right, that it's 500 years later and we're still doing this because it always works. All right, all kinds of good stuff. As always, there is a wonderful activity for everyone to take a look at. I would never let you down in that regard.
Hmm?